The table shows the number of shirts in a shop. How many shirts are white? So we can see that on the table, white shirts are in this column here. So to find the total number that are white, we need to add the white shirts that are cotton and the white shirts that are not cotton. And 27 plus 74 is 101. So that means 101 shirts are white. Now, how many shirts are there altogether? So we know that there are 101 white shirts, so we can find the number that are not white. So we have 56 cotton that are not white and 90 not cotton that are also not white. So that's 146 shirts that are not white altogether. But we want the total number of shirts. So we need to add the 101 white shirts and the 146 that are not white. And that means that we have 247 shirts altogether. Now we could do one long column addition and just work out 27 plus 74 plus 56 plus 90. But because we'd already found the number of white shirts, the easiest way to find the total number of shirts was to find the total that are not white and then add the total number of white and not white shirts. Complete this diagram so that the three numbers in each line add up to 150. So we want to start with a line that already has two numbers. So we don't want to start with this line here because there are two numbers that we don't know. So there are lots of possible answers for what these two numbers could be if we start with this line. But if we start here, 90 plus 40 is 130, and then we need another 20 to make 150. 9 plus 4 is 13, plus 2 is 15. And if we know that 9 plus 4 plus 2 is 15, then we know that 90 plus 40 plus 20 is 150, because we're adding multiples of 10, so numbers with a 0 on the end. And here we can have 70, because 6 plus 2 plus 7 is 15, and that means 60 plus 20 plus 70 must be 150. And we have 30 here, because 4 plus 3 plus 8 is 15, so 40 plus 30 plus 80 is 150. If we've worked out that 40 plus 80 is 120, then we need another 30 to make 150 in total. Or we could look at it this way. 3 plus 7 plus 5 is 15, so 30 plus 70 plus 50 gives a total of 150. We worked out that this number was 70, and 70 plus 50 is 120. So that means we need 30 more, 30 here, to make 150 altogether. Dan's book has 42 pages. Dan has read about half the number of pages. About how many pages could this be? Circle the number. So he's read half of a book with 42 pages. So to find the number of pages he's read, we can find half of 42. Remember, to find a fraction of a number, we divide by the denominator. And 42 divided by 2 is 21. Now we don't have 21 as one of our numbers, but that's because it says he's read about half the number of pages, so not exactly half, and that means we want the number that's closest to 21, so our number is 20. Sapna and Robbie have some biscuits. Altogether, they have 14 biscuits. Sapna has 2 more biscuits than Robbie. How many biscuits does Sapna and Robbie each have? So we can draw bars for Robbie and Sapna, and because Sapna has 2 more, we can copy Robbie's bar, and then the difference here will be 2. So now these 2 bars together must be 12, because 12 plus 2 is 14, and they have 14 biscuits altogether. So if these 2 bars total 12, to find each bar, we can divide 12 by 2, and that's 6, because 6 times 2 is 12. So these bars here are both 6, and that means that Robbie has 6 biscuits, and Sapna has 6 plus an extra 2, so that's 8 biscuits altogether. Notice 6 plus 8 is 14, and they have 14 altogether, and 8 is 2 more than 6, so Sapna has 2 more biscuits than Robbie. It is a 3-digit number. All the digits are odd. The digits add up to 7. What could my number be? So odd digits or odd numbers are numbers that end 1, 3, 5, 7 or 9. So we need a 3-digit number where the digits are odd and they add up to 7. So we could have 511, so 511 as the number, because 5, 1 and 1 are odd, and 5 plus 1 plus 1 is 7. We could also have 151 or 115. We could also have 1, 3 and 3, because those digits are all odd, and 1 plus 3 plus 3 is 7. We could have 313, or we could have 331. In these calculations, each missing sign is a plus or a minus. Write the missing signs in the circles. So here we can try out different things and see what works. So if we have 8 minus 7, that's 1. 1 plus 6 is 7, and then 7 minus 5 is 2. So our missing signs are minus, plus and minus. And here 8 plus 7 is 15, minus 6 is 9, minus 5 is 4. So here we have plus, minus, minus. There are 24 children in the nursery. 4 boys and 5 girls go outside. How many children are left inside the nursery? So if 4 boys and 5 girls go outside, that's 9 children going outside altogether, because 4 plus 5 is 9. So if there were 24 children and 9 went outside, we can work out 24 minus 9, and that tells us that 15 children are left inside the nursery, because if 15 are inside and 9 are outside, that's 24 children altogether. Write these prices in order from smallest to largest. So first we have 99 pence, but all of our other prices are written in pounds. So we can write 99 pence as £0.99. Then we have £10.50, £0.75, so that's 75 pence. Then we have £9, which we can write with a .00 on the end, because that tells us that we have £9 and don't have any extra pence. And we have £2 5 pence. So our smallest price is £0.75, and then we have 99 pence, because that's the same as £0.99. Next we have £2 5 pence, then £9, and our largest price is £10.50, because if the number of pounds is larger, it doesn't matter how many pence we have, the total amount will be larger if the number of pounds is larger. Dinesh is thinking of a number. He says it is more than 7, it is less than 20, it is an odd number. Write one number Dinesh might be thinking of. So we can remember that an even number is a number in the 2 times table, so a number that ends in 2, 4, 6, 8 or 0. And an odd number is not a multiple of 2, not in the 2 times table, so odd numbers end in 1, 3, 5, 7 or 9. Now we want a number that's more than 7, so we can't use 7, but the next odd number is 9, and that's more than 7 and less than 20, or we could have 11, 13, 15, 17 or 19, because they all end in 1, 3, 5, 7 or 9, so they're all odd numbers, and they're all numbers that are between 7 and 20. Circle all the fractions that are bigger than 1/5. So first we have 1/6. So the numerator is the same, which means we can compare 1/6 and 1/5 just by looking at the denominators. But we need to remember that the larger the denominator, the smaller the fraction will be. So 1/6 is not larger than 1/5. But now we have 1/4. That is larger than 1/5 because the numerator is the same, and so that we can compare the denominators, we can remember that the smaller the denominator is, the larger the fraction will be. And that's because the fraction bar hasn't been split into as many pieces, so each piece will be larger. 1/7 is not larger than 1/5 because 7 is more than 5, and a larger denominator means a smaller fraction. And now 2/5 is bigger than 1/5 because the denominator is the same, but here we have 2 pieces and here only 1. So 1/5 means that we have 1 part out of 5 of our fraction bar. 1/6 means we have 1 part out of 6, and we can see that that's smaller than 1/5. So that's why the larger the denominator, the smaller the fraction. If we split our fraction bar into 6 pieces, then each piece will be smaller than if we split it into 5. Now 1/4 is larger than 1/5 because we can see that this amount of the fraction bar is larger than 1/5, and that's why the smaller the denominator, the larger the fraction will be. 1/7 is less than 1/5, and with 2/5 we have 2 parts out of 5, so that's of course bigger than if we only have 1 part out of 5. Mr. Patel bought wood to make 2 shelves. The first shelf was 2.8 meters long, the other shelf was 3.9 meters long. What is the shortest length of wood Mr. Patel has to buy to make the 2 shelves? Circle the correct answer to the nearest meter. So one shelf was 2.8 and the other was 3.9. So let's work out how long the 2 shelves were together. Remember, when we're adding decimals, we copy down the decimal point and then we can use column addition to get 6.7. So the 2 shelves were 6.7 meters, which means that he needs 7 meters of wood. Because if he only buys 6 meters, then that won't be enough. There will be 0.7 meters extra that he needs. So that's why he needs to buy 7 meters. The total length of the shelves is 6.7, so he needs 7 meters. Here are 3-digit cards. We have 5, 7 and 3. Use the cards to make the number nearest to 400. So if we want the number to be as close to 400 as possible, we need to use the 3 as our hundreds digit. That's because any number with 3 in the hundreds will be less than 100 from 400. But if we use the 5, our number will be at least 100 larger than 400. So we need the 3 in the hundreds, and now we want to make the number as large as possible, because that will give us the largest number with 3 hundreds, so will be less than 400. So we can have the 7 as our tens digit and then the 5 in our ones. So 375 is the number nearest to 400 that we can make with these digits. That's only 25 less than 400.